Hey coders, today I'm going to solve the first problem from Project Euler, which is a website with lots of interesting math problems. I've made another short video you can check out if you're interested in learning more about Project Euler. They're a great way to level up your math skills and level up your coding skills at the same time. So today's problem is the first from the Project Euler website. Here's the problem. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. For our problem today, we're tasked to find the sum of all the multiples of 3 or 5 below 1,000. I always like to restate these problems in my own words so that I can make sure I understand the problem and also so I can start thinking about my plan to design a solution. So in this problem, we'll have a list that will contain the multiples of 3 and the multiples of 5 up to but not including 1,000. And then we'll want to find the sum of all the numbers on that list. Okay, let's get to it. Here we are in Scratch, and as I'm starting out, I want to go ahead and plan the solution that I'm building by putting in a few of the pieces that will help me break it into smaller parts. So I'm going to need a list, which we can find in the variables, and I'm going to call my list numbers to add. That's where I'll collect the multiples of 3 and the multiples of 5. I'm also going to use some sprites in this problem. I'm going to use the Scratch the cat and attach to him the code that will gather the multiples of 3. And then I'm going to use a different sprite. I'm going to grab this dog, and I'm going to attach to him the code that will add to my list the multiples of 5. And then once I have the multiples of 3 and the multiples of 5, I'm going to use one more sprite, and I'm going to use this elephant to add some code that will sum all the numbers on my list. And I'm going to quickly flip all three of these characters around so that I can eventually make them talk just a little bit as we're working through this solution. Okay, so I have my plan ready. Scratch will add the multiples of 3 to the list, then the little blue puppy will add the multiples of 5, and our elephant will sum all the numbers on our list. Okay, so back over to the scripts, and we'll work on Scratch the Cat's code first. I'm going to have clicking on Scratch be the event that starts the code. And after he's completed his part of our solution, he'll say, I've got the multiples of 3. So he'll have them added to our list. Now, the first thing he needs to do is check each number from 1 up to 999 to see if it's a multiple of 3. In order to count up one by one, we're going to create a new variable. I'll call this variable increment by 1. So I'll stick it up here at the top of my screen, and this is the count that will continue up to 999, and each time it increments by 1, we'll need to check if it's a multiple of 3. So in order to get it to count up, we need a repeat block, And I'm going to use this repeat until block. Let me make this a bit bigger for us. Okay, repeat until. And we'll keep repeating until our increment by one variable equals 999. I'm also going to delete this one so it doesn't confuse me later. So now we know how many times we're going to loop, and we need to add into here what we want to do for each loop. And we're going to change our variable called increment by 1. And we won't put our say block on yet because we haven't checked for multiples of 3, but let's test to make sure that this will count up to 999 when we click on Scratch. Yep, it did. And now we also can see that we need to add a block of code that will help us reset everything when we're ready to test again or run a solution. So when our green flags start, the program is clicked, we'll want to set some things back to 0. We'll set the increment by 1 back to 0, and we'll also grab this block and delete all of the numbers off of our list. Although we haven't seen any numbers on there yet, eventually we'll want to run several tests. So if we change the number that we're calling increment by 1, what we'll want to do next is check and see with an if statement if each one of those is a multiple of 3. And if it is, then we'll add it to the list. So I'll put that right here, and we'll add the increment by 1 number that we're checking onto our numbers to add list. And now we can attach that. We're getting closer. So now for this shaped block right here, we need to check and see if it's a multiple of 3, each number. To do that, we're going to use this mod block. And the mod is a block that tells us the remainder when we divide. So the first number in this mod block will be our variable, our increment by 1 variable. And we're going to check and see what the remainder is when we divide by 3. So I just click in there and type 3, and just to make sure you can see what I'm doing here. And if when we divide by 3, there is no remainder, or the remainder is equal to 0, then we'll know that that number we're checking is a multiple of 3. So we'll slide this into here, and we should now have a piece of code that is gathering multiples of 3 up to our increment limit up here. And I'm going to change this to 10 just so we can check it, run a little test. What we're hoping when we test this code is that it will increment 1 by 1 up to 10, and that each of the numbers as we run through this loop right here, if it is a multiple of 3, if the remainder when we divide by 3 is 0, then it will add those numbers to our numbers to add list. So let's give it a try. Fantastic. I've got the multiples of 3, and there they are up to 10. And let's go ahead and run this up to our problem's upper limit, up to 999, and see that we get the number of numbers that we expect on this list. If you'll notice here, there's a length of the list, and after we get all the multiples up to 999, it says that there are 333 of them. And since the biggest one is 999, And 999 divided by 3 is 333. This is all perfect, makes sense. It's doing what we want it to do. So our next job is to move over and code the multiples of 5. So we'll first gather and add all of the multiples of 3 to the list, and then we'll click on this puppy dog right here and add all the multiples of 5. And to get started, we can just move this code, copy it onto him. And before we move over there, we do need to add one more thing here. After Scratch the Cat has gathered all the multiples of 3, we need to set our increment by 1 variable back to 0 so that when we click the dog and run our multiples of 5 code, he'll be starting at 0 and running up to 999 again, but checking for multiples of 5. So to do that, I need to get from the variables this block right here, which is set increment by 1. Make sure you don't do another one of the change increments. We want to not change it, we want to reset it. And so just to make sure that you've got this code, there it is. And now we'll move over to our multiples of 5. Okay, so what are the things we'll need to change? We'll still have an upper limit of 999. We'll still go one by one through the list, but now instead of mod 3, we'll do mod 5. If the remainder when we divide by 5 is 0, then it's a multiple of 5 and we'll want to add it to the list. And right here we'll want to have him say, I've got the multiples of 5. And now to run this code as a test, and we'll run our whole program so far, let's set both of these upper limits to 20 on our multiples of 5 and on our multiples of 3. And we'll reset everything. Scratch says I've got the multiples of 3, 3, 6, 9, 12, 15, 18. Excellent. And our blue puppy says I've got the multiples of 5. Oh, but he doesn't yet have them. Let's see if we can figure out why. Sometimes we just have to save it. So let's try one more time. Multiples of 3, multiples of 5. There they are. Save before you run. That's true in most coding environments. So when we look over this list, 3, 6, 9, 12, 15, 18, there's multiples of 3. Then we have 5, 10, 15, 20. We have a problem that we're going to have to fix. To understand the problem with our code and also plan a way to solve that problem, this is a different way to model what we've done so far. So inside the blue box, after we run Scratch the Cat's code, we have all of the multiples of 3. If you could imagine a dot, dot, dot after the 30, this goes all the way up to our upper limit. And then after we run our puppy dog, gathering up the multiples of 5, here's the numbers he'd like to add onto the list. And the problem is some of these numbers are already on the list. Some of the numbers, like 15 and 30, are multiples of 3, and they are also multiples of 5. And we don't want duplicates on our list that we're going to sum. So what we need to figure out is how to add numbers from this list, the multiples of 5, so that we don't add those duplicates onto the list. Okay, we're back in the code for gathering up the multiples of 5, the code that runs when we click on the blue puppy dog. And to solve the problem, we're going to pull this out right here out of our if block. And as we're looping through the increments by 1 and checking each number to see if it's a multiple of 5, we're going to not only check if it's a multiple of 5 and automatically add it to the list, we're also going to check and see if it's not a multiple of 3. So we're going to have this little bit bigger block that's going to get even bigger. So we want to make sure that the numbers that are multiples of 5 get added, but if they're a multiple of 5 and 3, like 15 and 30, they won't be added. So we're going to check and see and only add numbers that are multiples of 5 and that are not multiples of 3. So we still need to rebuild our mod 3 equals 0 block so that we can do that check and make sure that a number is not a multiple of 3. So we have this not block, and now we're going to put this in here, the multiple for 3. This whole thing says, is it a multiple of 3? And we're looking to only add onto our list with this if check if it's not a multiple of 3, but it is a multiple of 5. So this is what we stick back in here. And now let's run our tests again. Set everybody back to 0. And there's our multiples of 3. And now we'll look for those multiples of 5. And what you'll notice here is that we have 5, 10, and it skipped 15 and went right to 20, which is exactly what we were hoping for, and we can feel confident that this block right here solved our problem. Okay, for our final step, we need to add all of the numbers on our list. And we're going to attach that final code to our elephant. So we'll start with when clicked, and then we're going to do a repeat block again. But this time, instead of with the incrementing, we're going to repeat for the length of our list. And there is a variable here that this is already created for us, the length of the numbers to add. So we're going to add them one by one, and we'll need to do that the number of times that the list is long. And we're going to need 2 new variables. We're going to make one called index. Whoops. And we're also going to make one called sum. And at the very end, that will be our final solution variable. So let's pull the sum one down right under this list. And I'll put the index down here too, but so that you know what's going on with the index, this is the one I'm going to use to refer to this number that's the count of our numbers in our list. And the sum will be the total as we add them. I need to go back over to scratch the cat where we have those initial variables, and we'll have the sum start at 0 every time that we reset, but we'll have the index start at 1 so that the first time that we loop, we're looking at the first number on our list. So now these all reset properly when we reset the whole code. So over on the elephant, we're adding each number as we loop through that whole list. So the first thing he needs to do is change the sum number by, and this is a block that is really helpful in solving these types of problems, the item, and then this represents the index number. So I can just put this index here. So when you see item index, it adds the value of the number that's at the index on this list. And then after in this loop, after we add that number, we need to also change the index by 1 and loop through it again. So change and make sure we change this to the index variable. So now when we loop through this, the number of times that the list is long, we should have the sum of all of the numbers on the list. And to have the elephant say the sum, we add this button right here, say, and we need a little bit different operator this time because he's going to say the sum variable first, and then he'll say is, oops, I keep getting those 9s in there, is the sum. So that he can say a complete sentence, but we can have him put in the sentence, the beginning word of the sentence or the beginning value, whatever the answer is. So to test this, let's go back to our values that we started out with that were a given in the problem. So if you'll remember in the problem description, it said that when we sum the numbers less than 10, they add up to be 23. So that means if we change these to 9, because we don't want to include 10, and run all of our code, we should get 23. So let's give it a test. Multiples of 3, multiples of 5. Well, I already can see that we have some kind of bug because this should have gone all the way up to 20. Oh no, that's right. We changed it. So this is what we want. These are the multiples that we're looking for. And 23 is the sum. So perfect, fantastic. We're ready to run our final solution. We're going to get the multiples of 5 up to 999, the multiples of 1 up to 999. Let's make sure we save and reset everything. I've got the multiples of 3. I've got the multiples of 5. 233,168 is the sum, and that is also the solution to the first Project Euler problem. I hope that you enjoyed following along and hopefully coding along with me as we solved that first Project Euler problem. I want to mention one solution, a different way to solve the problem that you should absolutely try on your own. Instead of looping through the increment by 1 list 2 times and having 2 different sprites or 2 different sections of code, we could have just put that all into one sprite, and when we checked in the if block, we could have had an OR operator, and we could have checked to see if each number as we incremented was a multiple of 3 or a multiple of 5, and if it was either of those, then add it onto our numbers to add list. So that's just a different way we could have solved this problem. I hope you had fun. I hope to see you next time. Don't forget to like and subscribe.